Why does the universe seem so precisely calibrated for life? This is the essence of the fine-tuning problem, which examines why fundamental constants, like the speed of light, the gravitational constant, and the cosmological constant, are set within incredibly narrow ranges that allow stars, planets, and life to exist. Slight changes in these values would result in a vastly different universe, one likely incapable of supporting life. For example, if the electromagnetic force were slightly stronger or weaker, atoms wouldn't form as they do, preventing the chemistry necessary for life. This remarkable precision raises profound questions. Is this balance due to random chance, the result of deeper physical laws, or evidence of a multiverse where countless universes exist, each with different constants? Some even argue that it points to intentional design, suggesting a purpose behind the cosmos. Regardless of the explanation, the fine-tuning problem drives inquiry at the intersection of physics, philosophy, and cosmology, challenging us to explore the fundamental nature of existence and whether the universe's precise parameters are an extraordinary coincidence, a necessity, or something more.
The fine-tuning problem arises from the observation that the fundamental constants of nature, such as the speed of light, c, the gravitational constant, g, and the cosmological constant, lol, appear to be exquisitely set within narrow ranges that allow for the existence of a stable, life-permitting universe. If these constants were even slightly different, the universe would be vastly different, likely incapable of supporting stars, planets, or complex life. This raises profound questions. Why do these constants take their observed values? Is their fine-tuning a result of chance, necessity, or design? Example: the strength of the electromagnetic force determines the size of atoms. If it were stronger, atoms would collapse. If weaker, atoms wouldn't form, precluding the existence of chemistry and life. Analogy: the fine-tuning problem is like balancing a pencil on its tip. Any deviation from the perfect position would cause it to fall. The universe is governed by several fundamental constants, each playing a crucial role in shaping the cosmos. Among the most critical are the gravitational constant, g, the fine structure constant, Afer, the cosmological constant, Lil, and the masses of elementary particles like the proton and electron. These constants dictate the behavior of forces, the stability of matter, and the structure of spacetime. Slight variations in these values would lead to universes fundamentally different from our own, most of which would be hostile to life. Example: the ratio of the electromagnetic force to the gravitational force must fall within an incredibly narrow range to allow stars to burn steadily for billions of years, a necessary condition for the emergence of life. Analogy: fundamental constants are like ingredients in a recipe for a cake. If the proportions are slightly off, the cake might not rise, crumble, or even be edible. The extreme precision required for many of these constants raises questions about their origin. For example, the cosmological constant, which governs the rate of the universe's expansion, is fine-tuned to approximately 1 part in 10 to the power 120. A slightly larger value would cause the universe to expand too rapidly for galaxies to form, while a slightly smaller value would lead to gravitational collapse. Such improbability suggests that either the constants are determined by unknown principles or that their values are the result of an extraordinary coincidence. Example: if the strong nuclear force were slightly weaker, protons and neutrons would not bind, preventing the formation of atomic nuclei and the periodic table of elements. Analogy: the improbability of fine-tuning is like throwing a dart at a dartboard the size of the observable universe and hitting a bullseye the size of an atom. One explanation for fine-tuning is that the constants of nature are not contingent, but are determined by deeper physical laws. In this view, the values of the constants may be the only values consistent with a self-consistent universe. However, no fundamental theory has yet been discovered that predicts these constants uniquely, leaving the question of their origin unresolved. Example: string theory suggests that the constants may emerge from the geometry of extra-dimensional space, but it predicts a vast landscape of possible universes, making fine-tuning still appear coincidental. Analogy: necessity as an explanation is like solving a puzzle where every piece fits in only one specific way. It suggests the configuration is inevitable, but the puzzle's existence remains unexplained. Another possibility is that the constant's values are the result of pure chance. If the universe is the only one that exists, its constants might be randomly assigned, and we happen to live in the rare universe where they permit life. This explanation, while simple, is unsatisfying to many because the odds against such precise fine-tuning are astronomically high. Example: the anthropic principle states that we observe the universe to be fine-tuned because we exist to observe it. Universes with unsuitable constants would not contain observers. Analogy: chance as an explanation is like winning the lottery on the first and only ticket ever sold. It's possible, but extraordinarily unlikely. The multiverse hypothesis posits that our universe is just one of many in a vast multiverse, each with different values for the fundamental constants. In this scenario, fine-tuning is a selection effect. Life emerges only in universes with the right constants, making ours one of many possible outcomes. This explanation gains support from theories like eternal inflation and string theory, which predict the existence of multiple universes. However, the multiverse itself is unobservable, making it challenging to test scientifically. Example: in eternal inflation models, bubble universes form with different physical laws and constants. Ours happens to be one of the rare bubbles where conditions allow for life. Analogy: the multiverse is like a cosmic lottery with billions of tickets. Our universe is simply one of the few winners. Another explanation is that the universe's constants were deliberately fine-tuned by an intelligent designer or external agency to permit life. This hypothesis often appears in philosophical and theological discussions, but is not a scientific explanation because it cannot be tested or falsified. Proponents argue that design is a more plausible explanation for the extraordinary precision of the constants than chance or necessity. Critics, however, contend that invoking design introduces further questions about the origin of the designer. Example: some interpretations of the fine-tuning problem view it as evidence of a purposeful cosmos created with life in mind, drawing parallels with arguments for intelligent design. Analogy: design as an explanation is like finding a perfectly calibrated machine in the wilderness. Its precision suggests intentional creation rather than random assembly. The observed fine-tuning of constants may result from anthropic constraints. Conditions necessary for life to exist dictate the constants we observe. For example, regions of the universe with extreme conditions might exist but remain uninhabitable, biasing our observations toward life-permitting parameters. This view integrates with the multiverse hypothesis, but does not independently solve the fine-tuning problem. Example: the habitable zone of a solar system represents an observational bias. Life evolves only where conditions permit, and these regions are overrepresented in biological studies. Analogy: observational constraints are like only seeing swimmers in shallow water. It doesn't mean the ocean is entirely shallow, only that deep regions are unsuitable for swimming. The fine-tuning problem has profound implications for both physics and philosophy. Scientifically, it drives the search for a theory of everything that might explain the constants as emergent properties of deeper principles. Philosophically, it raises questions about the nature of existence, the role of consciousness in the universe, and the possibility of purpose in the cosmos. These discussions often intersect with metaphysical ideas about the multiverse, design, and the anthropic principle. Example: quantum cosmology explores whether the constants of nature could emerge from quantum fluctuations during the birth of the universe, potentially resolving fine-tuning as a natural outcome. Analogy: The fine-tuning problem is like finding a beautifully ordered garden in the middle of chaos. It invites questions about its origin and purpose.